Okay, so let us move to tutorial 2. So tutorial 2 is about running dynamics simulation. Running dynamic simulation, so meaning that we try to set the rank of the influence. Let's say in 20 days, the influence may change from 1,000 to first day maybe 1,000, second day maybe 1,500, etc. Okay, and then let's see how the performance of our unit process, our system works. So this is in the tutorial 2. So the objective is set up a graphic interactive controller and running interactive simulation. Okay, so we try to make the interactive controller. Okay, so this one is uh, we will use the tutorial 1. Okay, and then we save it, and then we will use this one as tutorial 2. Otherwise you have to build it again. Okay, and then okay, access the parameter by right click. Okay, we go to the influence, still in the simulation mode. Okay, we still in the simulation mode here like this, and then we right click on this, and then we go to output variable. Let's see, this is okay, flow first. This is flow, and this is the flow data. Alright, access the parameter by right clicks and flow data, and flow submenu should be over there. Okay, so from here we drag this, you see here, so we drag this one and then put it here. Okay, you can see this one is 2000, this is default value, and this is the 0, this is the minimum per value, and then this is the maximum value of the flow, the inflow. Okay, influent flow. All right, so now we need to submit, and then we will change this one from in here. They said that we have the property and maximum 0 for mean and 12,000 for maximum. So we change this one into 12,000. Okay, and then we make sure that the slider is selected. Okay, yeah. Okay, so 0 to this one, and rename the control tape by maybe to input 1. From here we type flow controller, so this is a flow controller, flow control. Okay, flow control, and in control, so it means that influent flow is, it can be changed from 0 to 12,000 cubic meter per day. Okay, so you can test slider control by dragging and the small slide. Okay, all right, we can check it. See that you can slide, and then you can change the value. And if you want to get 2000 back, you can put in here 2000, or you can just set this one, select this one to reset it to the previous value. Okay, so created output graph. All right, we would like to create the output graph. So we create a blank. Okay, so we will create a blank tape here. This is a great new graph tape. Okay, new table and a new graph. We don't use table, we use graph. So this is a graph, and then from here, effluent, select on it. Okay, output flow here, and from here we drag it to here. Okay, yeah, save it. Flow, and then after that accept. Okay, is that it? So we this one. Next is we put the right click on the right. Okay, we right click on the, where is that? Okay, effluent. Okay, we right click on the effluent by using the concentration. Okay, so we create a new plot, one more plot. Okay, we create another one. This is only to see the outflow. Okay, we can change the name here to influence. Okay, influence flow or what? Okay, change to okay, never mind. Okay, we put this one first. All right, later we will change this name, but this one is this is one graph, this is inflow. Okay, and then we have another one. Select this, we select output variable concentration. Okay, output concentration here, see that, output here concentration, and then we select the total suspended solid. We select the concentration, variable concentration, and use the total suspended solid. Okay, so here this is total suspended solid, and this is the plot. Total suspended solid, drag it and then put it here. See that? Okay, so we have total suspended solid, and this is the inflow, and this is the time. Okay, you can see here same. Alright, so we change the name. Alright, click this one, influent flow, then influent flow. Okay, output, that is press button, and then output graphic window. Okay, so this one means we would like to change the minimum and maximum of the flow first. Okay, then we have two actually. Okay, okay, for the flow is from 0 to 10,000, and from the total solid is from 0 to 150. Okay, so this one, see that, from here you have to unlock this one. If you lock it, mean you change one, you change all. Let's say, see that? Okay. So we change this one. This is 10,000, and this one is 150. No, 150, and then we accept it. Okay, and then rename. Okay, now this name effluent flow and effluent TDS. TSS. Okay. So we change the name here. Come, effluent flow and effluent TSS and effluent TSS. Okay, and we submit. Okay, so now you can run. We can run the simulation. So now we're ready to run the model or the controller. You need to run Dynamics locate and then specify the simulation time. It's 20 day by entering the value directly into the stop time. Or by repeatedly clicking the on the arrow adjacent to the field to increase the value 1 day for each click. Okay, so this one you can try it. Okay, so this one is let's say we put 20 day. Okay, we get 20 day and then we do the simulation, something like this. You see that? So when it start moving like this, we can increase this one, increase the flow. Let's say we increase the flow, and then you see how the effluent will. Okay, you see that? So when the see, so when the effluent, let's say 8,000. So let's say it's 8,000. When the effluent is okay, we do it again. Let's say we start from the 2000. Okay, 2000. So when this flow increase, so you can see that when the flow increase, suspended solids also increase, and then in one time they see, so one time is like when it reach like around almost 7,000. So now it's like overloaded. Okay, this is overloaded, so meaning that the suspended solid is like too much inside the secondary clarifier. I mean the suspended solid is too much getting out from the secondary clarifier. Look at this one. So example where the flow increase the control bar. Now that the upper graph look different at 1% below. It depends. Okay, so running the simulation again by at this time adjust the effluent flow by dragging the 2000 from 2000. If the simulation proceed too quickly, you can artificially slow down the simulation by internet delay. Okay, so you can see that we will now take the more detailed look at the upper plant performance by investigating the effect of increase the flow in secondary clarifier. We will first step. Okay, so we set up. We look at the secondary clarifier. Okay, this one is 2000. We make flow 2000 back, and then I investigate the change in solid profile inside the final clarifier, secondary clarifier, by running the model at a higher flow rate, meet the simulation storm condition to investigate the effect or increase the flow on the final capacity quality. Our first step graph set up in the outflow solid. Okay, so we would like to see the So this is our secondary clarifier. We create one more graph. So here you can see like this. Okay, not the process itself. We select not the process itself, but this one, connector. Right click on it. And then initial, sorry. Okay, access the concentration and output value by right click, selecting the okay, clarify by right click on the object and selecting from the output variable concentration. So here output variable concentration. Okay, here. So this is output variable concentration, total suspended solid. Drag the total suspended item to the blank area. Alright, existing tape with the tape automatically. Okay, reverse actual array. Okay, suspended solid. Okay, we select suspended solid, submit. Okay, we select it and then we change the graph. So this one will be the patch control. Okay, our graph, bar chart type, bar chart horizontal. Change the axis max to 5000. This one we change to 5000. Then rename the graph, right click, find a greater solid profile. Okay, so we change to final clarify solid profile. Okay, we change this. Final clarifier solid profile. Okay, 5000. Okay, so make sure that 2000 is here, and then run. Start on 10 day. Okay, 10 day. Figure. Okay, then we run it. Okay, it's running 10 day. Get it? Oh, what happened? I think it's fine. wrong graph. Okay, it should be output. Oh, sorry, just now it's different. See, we select from here, but actually it should be, because we would like to see the profile of this one. So select on the object itself. Select on the object, output, and concentration in layer. Then after that, this total assessment is solid in layer. I drag it. So now this one will be created automatically for us, but still we need to change this one in horizontal. Okay, and then this one will be final clarifier solid profile. Okay, and this one will be 5000. Okay, so it should be like this, and index here is refer to the depth of the clarifier. Okay, so 10 is the bottom one. Okay, so now we run 10 day. Yes, this one. Okay, so we got around 4000 at the bottom. Sorry, what did it? Yeah, around 4000 at the bottom here. See, same. So increase the effluent rate to a high value, for example 5000. Controller stop time 20 day, and see what happened. So let's see. You can see that this is like 10 day. We got around 4000 at the bottom. Let's say we increase this one to 5000 cubic meter. Okay, and then run 24 day, 20 day. So what happened? Yes, it's increased a lot. Okay, so it's increased a lot. Let's see how much this one. It's around 12. Okay, let us change this one into we put this one is 12,000. Okay, so we run it again. Okay, see that? Just now we got around 4000. Just now we got around 4000. But now this is increased a lot. 2000. 2000. See? So this one become around 4000. Let's say 2000 for 20 days. So not yet. Simulation still running for 20 days. So it's about, let's see how much. Okay, it's around, it's almost like 4.8 thousand MLD, and then we put like 5000 here. Okay, 4000. So it become almost 10. Okay, this is almost 10,000 cubic with ppm at the bottom of the tank. Okay, so that's all for tutorial 2. So we are going to proceed, we break, and then we proceed for the tutorial 3.